Hello and welcome to Clutches and Drivetrains. My name is Per Marklund and I work at Luleå University of Technology, and this presentation is a part of the course Advanced Machine Elements. This will be an introduction in clutches and drivetrains. However, at the end of the presentation we will reach quite far and quite in depth into the function of how clutches work. This is part 1, and I have divided this presentation into a number of parts, and I try to keep them around 10 minutes each. So in total, this is what I will go through. Here we have clutches, introduction, wet to dry clutches, applications, calculations, grooves, permeability, ATF. Tribological changes, challenges, wear, clogging of pores in friction material, lubricant failure, and hotspots. And also we'll talk about drivetrains. Front-wheel drive, rear-wheel drive, four-wheel drive, all-wheel drive, and I will discuss the difference between traction and handling. So, if we start then. Clutches. A clutch transfers torque with help of friction. The difference between a clutch and a coupling is basically that a clutch allows different rotational speed between input and output shaft, and still it transfers torque. A coupling normally is connected, so you can't have any slip between the two shafts. There are two main types, dry clutches and wet clutches. Please observe that there is quite a lot of similarities between clutches and disc brakes, or radial clutches and drum brakes. The only difference is that if you have a brake, one of the parts is standing still, and if you have a clutch, both parts are rotating, or both shafts. Here to the right, we see a figure that shows a clutch from a car with manual transmission. This is normally what people think so when you are saying the word clutch. Moving on, the powertrain. This is where the clutch is located. Here to the left we have the internal combustion engine. Then we have a clutch that connects the crankshaft of the engine to the gearbox. We have a prop shaft that goes to the rear axle, but this could also be the front axle in a front wheel drive car. Here at the beginning we have high RPM and quite low torque. At the end we have low RPM and high torque. And that's also one reason why we should have the clutch here in the beginning, because the lower torque we have to transmit, the easier job for the clutch. So, the friction clutch then of a disc type. This is a really simplified schematic of a friction clutch. We can see that we have an input shaft here that is rotating, and we have, in this case, only two discs. And since we have a distance here in between the discs, the other shaft or the output shaft is not rotating. If we push these two together, because of the friction that is between these two discs, the output shaft will also start to rotate. And this is then a dry clutch. The only difference with a wet clutch is that it's submerged in a lubricant, an oil of some kind. So, how does a clutch engagement look like when you go from a fully disengaged shaft to fully engaged shafts? As always, you can start by looking at the Strebeck curve. Here at the Strebeck curve we have different regimes. Boundary lubrication, where we have full contact between the asperities of the two surfaces. We have mixed lubrication, where we start to separate the surfaces with the hydrodynamic forces, and we have full film lubrication, where they are fully separated. Most important for clutches are this area, because we want to transfer torque, meaning that we want to have a high friction. and therefore the full film lubrication stage isn't as important as the mixed and boundary. If we look at measurements from a real engagement, we have the hydrodynamic part 1, boundary lubrication part 2, and engaged clutch 3. And you can see the figure is the same as I showed the schematics earlier. Here at the figure we can show the RPM that goes from 3000 RPM to 0, and the torque that is transmitted during the engagement. This clutch is actually here working as a brake, so the speed is not only difference in speed, it's actually it's the actual speed on the input shaft, and the output shaft is stationary. So we have a large flywheel that rotates with 3000 RPM, and we start to engage the clutch. Here you can see that the torque in the hydrodynamic part is slowly increasing, and since it's not that high torque, the RPM doesn't go down very much. Here we reach the boundary lubrication part, and you can see that the torque is high and quite steady, and the decrease is quite fast in RPM as well, until you reach here when the RPM is 0, part 3, full engaged clutch. What you can see here is just that the flywheel is going back and forth because of the weakness of the test ring. That's this red part here. A dry clutch then. Well, what we basically don't have is the hydrodynamic part. So the difference between a wet clutch, where we have a little torque transfer in the hydrodynamic part, is that we don't have much torque transfer at all in a dry clutch, because the air, when you have the air between the plates, it doesn't really transfer any torque. So a dry clutch then. As I said, a dry clutch can be used in a car with a manual transmission. A dry clutch normally works in air. It could also work in other gases, but the simplest is always to have it working in pure air. Dry clutches are used for dry environments, and where we have enough diametrical space, because we need to have a quite large diameter, since we normally only have one clutch disc in dry clutches. And they are used where you have short engagement time, because air doesn't cool the clutch very much, which means that we should have short engagement so we don't produce much heat that we need to cool off. Often we only have, as I said, one clutch disc, and we will see the difference to wet clutches later on. So the advantages with the dry clutch is that it can work in a dry environment. It's cheap. You don't have to have any oil pumps or oil sumps or whatever, and it can handle large torques. The disadvantage with the dry clutch is that it can only be used for short engagement. You can smell when you are driving the car, if you're trying to park a heavy trailer or something, that it starts to smell. If you are working a lot with the clutch, slow speeds, high torques, and that because you overheat the clutch. It is also sensitive for contaminations like lubricants. It must work in a dry environment. It not only can, it must work in a dry environment. This might be a problem when the crankshaft seal starts to leak, and it leaks oil onto the clutch in a manual transmission car, and you got into problem. The dry clutch in the powertrain. This is similar to the picture I showed earlier, and here you can see a more detailed picture on the front wheel drive car. Please observe that the scale here is not that good. Normally the transmission doesn't need to be this large. This is how it built up. You have the flywheel close to the engine, you have the friction disc, and you have the pressure plate which presses these together. You have a disc spring that presses it together, and you have a disengagement bearing. This is what you use when you are pressing the clutch pedal to disengage the clutch. Then you press this on the spring. It can be normally mechanical or hydraulic transferred. It can also be electronically controlled clutch, like in different AVD systems or in automatic transmissions, where we also have the clutches. And by that I think we end part 1. And in part 2 we will move into wet clutches instead. So thank you, and let's meet again in part 2. Bye.